Section 4.5, scatter plots and correlation. Essential question. How do you determine if there is a correlation between two variables? So there are three different types of correlation. There's positive correlation, negative correlation, and no correlation. So positive correlation, the graph will go up from left to right. I'm going to put L to R for left to right, meaning that as X increases, Y increases. For negative correlation goes down from left to right. And as X increases, Y decreases. No correlation means that there's no relationship between X and Y. So there's no trend to the data. And then our line of best fit shows the trend that the data is displaying. So a line of best fit kind of goes in the middle of the data and in the general direction that the data is going. So a line of best fit, if you look at the top one, the line goes up from left to right. The negative correlation goes down from left to right. No correlation, you don't draw a line of best fit because there's no trend for the data. So for definition of line of best fit, we're going to put the trend of the data. So where is the data going? A big thing about line of best fit is it's used to make predictions as well. All right, let's get to the first example here. So which of these shows the line of fit for the best line of fit for the scatter plot? Well, first of all, a line of best fit has to be a straight line. So if you look at A, B, C, and D, D isn't even a straight line. So we can eliminate that one immediately. Now we're going to look at A, B, and C. All the data points are the same, but one of them is going to go through the data the best. If you look at A goes through one dot, and it's got a couple that are fairly close to the line, but then it's got two more that aren't close at all to the line. So I would say A is probably not our best line of fit. That line is going down, and it looks like our data is going up from left to right. Let's look at letter B. Letter B has a couple points that fall on the line, a couple points close to the line, and really just one outlier, which you are going to have some outliers on a scatter plot. They're not all going to fall close to the line, but you could have an outlier. B looks pretty good, but let's look at C before we make our decision. C, we've got one dot on the line and two close to it, but then two pretty far away. I would say that C is not our best line of fit. It is letter B. Okay. Determine if this graph shows correlation. If it does, draw a line of fit and describe the meaning of the situation. So let's see if we're able to draw a line of best fit for this graph first of all. Well, it looks like our data is going down from left to right. So I can draw a line of best fit. Down from left to right means negative correlation. And now we have to describe the meaning. So let's look at our labels in order to be able to do that. So our title of our graph is Computer Sharing in Maria's School. we have the year, and we have students per computer. So how many students shared a computer each year? All right, so one thing that can help you with describing a graph, if you're struggling, is taking two dots on the line and writing their ordered pairs. So if I pick this one, that one is the year 2002, and my y value is 25, so 2002 and 25. And then if I pick another one down here, we'll pick that one, so 2008, and we'll say about 12. So we're going to write a sentence talking about what x is doing and then what y is doing. So let's look at our x values, 2002 and 2008. So time is going by. So we're going to say as time passes, and I'm going to label time as our x value because x was our year. What's happening to y? Well, we went from 25 down to 12. So this number is decreasing. Our y value is students per computer, so that's what's decreasing. So as time passes, the number of students sharing a computer decreases. So if you think about that logically, as we use more technology and more technology in school, that makes sense. We're not going to need as many kids to share a computer because we're getting more technology all the time. Schools are getting more computers because they're being used more often in classes. So we'll say that this was our y. So we're referring to x and y when we write our sentence. All right, second example. Calories burned during exercise. So let's try and draw a line of best fit. This data seems to be moving up from left to right. So that would be positive correlation. And then if I need to write a sentence, I can take a couple points again. So let's do one way down here. So this, look at our range. So we're going from 0 to 10 minutes. So we'll say this is at maybe 2 minutes. And then we're going from 0 to 100. So we'll say maybe 10. And then we'll pick another dot here. We'll say that's maybe 42 minutes and about 380. Now keep in mind, this graph is talking about the calories burned during exercise. X is our time in minutes, y is our calories. So we're going to write our sentence referencing x and then y. So let's look at our x values. They're going from 2 to 42. So our x values are increasing. So the time in minutes I work out is going up. So we'll say as you work out for longer, as in our time. Let's look at our y value, goes from 10 to 380. So that's increasing as well, and that's our calories burned. So we'll say the calories, that's our y, you burn increases. So as you work out for longer, the calories you burn increases, which makes sense. The longer you work out, the more calories you're going to burn. All right, this one is talking about weightlifting. So let's see if we can draw a line of best fit. So remember, straight line going through kind of the middle of our data. What way is our data trending? It's trending down. So that is a negative correlation. So our labels on this graph, we're talking about weightlifting, the weight in pounds, and the repetitions. Now repetitions is how many times are you lifting up that weight. So keep in mind that's what repetitions means. All right, let's pick a couple ordered pairs to help us write our sentence. So we'll have about 20 and 12, and then we'll do 120 and 2. So let's look at our x values. Our x values go from 20 up to 120. So our x values are increasing, x being our weight. So as the weight, which is our x, increases, and then our repetitions is y, it goes from 20, 12 down to 2. So the number of repetitions, y, decreases. Which, if you think about that logically, it makes sense. When you're holding a really light weight, you can do a lot of repetitions. You can lift that weight a lot of times. When you're holding a really heavy weight, you can't lift it very many times before your arms get tired. So you can't do as many repetitions when the weight is really heavy. All right. So this is our first one where the dots are scattered all over the place. They're not going up from left to right. They're not going down from left to right. So this means that there is no correlation. So let's look at what there is no correlation between. We're looking at library fines. X is our books borrowed. Y is our fine in dollars. So that just means there is no relationship between books borrowed or X and fines, which is our Y. So those two things, one doesn't depend on the other. If you borrow more books, you don't necessarily have more fines. If you borrow fewer books, you don't necessarily have less fines. So though they found no relationship between those two things. Some people borrowed a ton of books and never had fines. Some people borrowed only a few books and had lots of fines. It could be all over the place. Okay, last one that looks like this. So we've got one more with correlation. This one is going up from left to right. So positive correlation. Let's look at our labels. Car dealership revenue, the year, and the revenue in hundreds of thousands. So let's pick a couple years here. So this is our first one that's pretty close to my line of fit. So in 2002, $1,000 of revenue. And in 2006, the revenue was up to about 9. So as time went by, as time passes, the revenue, our Y, let's look at what our revenue does. It goes from 4 to 9. 400,000 to 900,000. So the revenue increases. So over time, the revenue at car dealerships has increased. Okay, last one. This one you are going to make your own scatter plot. So we've looked at a bunch of different scatter plots in this lesson. Now it's time for you to make one. So we're going to make our X and Y axis. We know that our X-axis is shoe size. And we know that our Y-axis is height. All right, so let's look at our numbers for shoe size. Well, our smallest shoe size is 8.5. Our biggest shoe size is 12. So maybe I will start at 8 and go up by 1. So 8, 9, 10, 11, 12. And then let's look at our heights. Our smallest height is 67.5 and our biggest is 74. So let's start at 67. Extend this a little bit more here. All right, now we're going to plot those points. So 10, oh, I just realized I wrote this wrong. Okay, so I'm going to try to fix this really quick here. I was putting the wrong numbers on the wrong axis. Okay, so we need this one to go from 8, 9, 10, 11, 12. And this one to go from 67 to 74. So 67, 68, 69, 70, 71, 72, 73, 74. Sorry about that. Okay, try again. All right, so our shoe sizes, so 8 1/2. So the first one is 10. And then 70.5, 10 1/2, and 71, 11 and 72, 9 and 68.5, 12 and 74, 8 1/2 and 67.5. Okay. So let's draw a line of best fit for our data. So you'll notice we have positive correlation. So this means that as our shoe size increases, our height increases, which is generally true. Generally, if you're taller, you have a bigger shoe size. If you're shorter, you have a smaller shoe size. Okay, so now we're going to use our line of best fit to answer a few questions here. So it says, what height would you expect for a shoe size of 9.5? So here's how we do that. We're going to go over to 9.5 for our shoe size, which is about right here. And then I'm going to follow my lineup and stop once I hit my line of best fit. So my line of best fit is right there. If I look across, it's at about 69. So we would assume our height is going to be 69 inches. All right. What height would you expect for a shoe size of 11.5? So let's go over to 11.5. Follow our lineup till we hit our line of best fit. Go across. I would say that's at about 73.5. Again, you're making a prediction, so it won't be exact. And then our third one, what shoe size would you estimate a 73-inch person to be? So 73, if I go across, I'd land at about right here, which is size 11. So that's how a scatter plot and a line of best fit is used to make predictions. The line of best fit helps you make a prediction for a data point that is not in your data set. Summary.